We already mentioned this several times. I don't know why I keep going to the wrong slide. Okay, we had left off here. Here we are. Global warming is making spring allergies bloom earlier. So as global warming happens, temperatures increase. We already said before in other contexts that winter arrives later, so fall is extending into later and later in the year, and spring arrives earlier. The length of the day, which matters in terms of light for photosynthesis, doesn't change. The temperature changes, and some of the spring bloom activities start earlier. So the growing season is definitely getting longer, as we saw, but we will see that that doesn't mean food production necessarily goes up. There are impacts that are positive and negative there. So this is a infographic from National Jewish Health, njhealth.org. I'll just go through it. Researchers say global warming is leading to larger plants and earlier and stronger pollination. Larger plants and earlier and stronger pollination. This again relates to CO2 fertilization, the direct impact. What you can do, start early on allergy medication. Trees may bud early, so don't wait to take medicine. Most people have to start taking antihistamines before the pollen season actually starts. But if the pollen season is starting earlier, they better be aware of it so that they don't get caught taking antihistamines later. So take antihistamines at night. Their effectiveness peaks in the morning. Nasal washes are natural alternatives. Follow proper water prep guidelines. So there is a way to wash out the irritating pollen from your nasal passages and reduce inflammation and so on. 385 plant species in Europe are blooming earlier than ever. 385 plant species. That's not a small number. In US and Canada, ragweed season is up to 27 days longer, as we saw. It went from -1 day over Texas to 27 days over US and Canada. Allergic rhinitis, nose problems, generates more than 12 million doctor visits each year. 35 million Americans are allergic to pollen and mold. Mold is another issue with global warming, CO2 and humidity and so on. Common spring allergies, tree and grass pollen, mold spores, dust mites and cockroaches, and animal dander. Right? So we are not talking about impacts of CO2 and warming on animal dander here, but nonetheless, that's part of the allergy season as well. Looking again at ragweed, this is ragweed pollen counts rising with increasing carbon dioxide. So this shows the work by Ziska and Caulfield. Ziska, one of the co-authors here. Scientists have grown ragweed in chambers where they can control the atmospheric carbon dioxide levels. These studies have found that ragweed plants produce much more pollen when carbon dioxide levels are increased. So here you are, CO2 pollen production in grams per plant. The year 280 so year 1900, we came out of the last glacial maximum and reached CO2 levels of 280 ppm. We bumped it up to 370 by 2000, and 720 ppm is expected by 2075. And in the experiments, the pollen production goes up significantly from 5 grams per plant here at 280 ppm to 20 or more at 720 ppm, so 4 times the pollen production in grams per plant. You can imagine the number of plants and the amount of pollen that would end up producing. Okay, so the indirect effect of CO2 is the negative impacts on crop yields and food production, food security issues, nutrition issues. So this is different, slightly different than the biodiversity and allergies and other toxicology, pharmacology impacts. Okay, so here US maize, India's wheat and African maize are shown, and global average temperature change in degrees centigrade from pre-industrial is used to estimate yield changes. Okay, so you can see that the yield change can be really massive. 60% or higher for Indian wheat. Wheat is mainly a winter crop, so warming obviously is going to affect wheat. Maize in Africa and US are also going to be affected by a combination of warming extremes, precipitation changes, and so on and so forth. So this is going to seriously lead also in terms of competition for biofuels, animal feed, price ranges, nutrition. There's plenty of evidence, as we will see along in the course, that the micronutrients in the plants are also reducing during because of warming, and there is a reduction in the protein content of some of these crops as well. So here is another example: increases in atmospheric carbon dioxide and anticipated negative effects on food quality. So this is Christie, Ebby, and Ziska, the authors here. The summary points are: high atmospheric concentrations of carbon dioxide increase the growth of cereal crops. At the same time, CO2 decreases nutritional value of key staple crops, particularly rice and wheat, by lowering concentrations of protein, micronutrients, and B vitamins. From 2015 to 2050, elevated CO2 could result in an additional 125.8 million disability-adjusted life years, or daily, as they're called. This is 95% significant at 95% confidence level. Attributable to a greater burden of infectious diseases, diarrhea, and anemia. Impacts are projected to be greater in countries in Southeast Asia and African regions that are already highly vulnerable to climate change and are not the major contributors historically to climate change. Okay, so paying a price for richer countries' influence on climate change. Implementing strategies to reduce greenhouse gas emissions could avert as much as 48.2% with 95.8% confidence of health burden, compared with traditional public health interventions that could avert by about 26.6%. So reducing emissions is the best strategy. Of course, other traditional public health interventions can also help, but it's not like waiting till the crops are already losing their nutritional values and then you're trying to compensate for it by other measures. It's better to reduce emissions and reduce the impacts of crop nutrition in the first place. Okay, so I will leave this here and then conclude the chapter with the next podcast. Again, like the previous one, this is a short chapter but very critical in terms of human activities, CO2 increase, plant responses, and health outcomes, direct and indirect. Okay.